doing our own business, because they have statistical for business, or business statistical. So we say that practical, real life. Practical real life. So those are the areas. So statistical probability has tens, it means more than tens applications in the human life. Okay, and especially in engineering, in every field of engineering, we do find the application of probability and statistics very important. Okay, in industries, it's even kinds of, it's more than important. So now, let us go to the, to start our module, probability and statistics, and we'll be starting with the first concept of what? The first concept which I've mentioned to you, which is called what? We say that introductions of statistical estimation. So let us start this business. 3.1, introduction, say with me. So this is lecture 1, as it has been lecture 1, but it's still lecture 1. Introduction of statistical estimation. So introduction of statistical estimation. Okay. So the first sentence that I would like to make, we say that in, okay, we say that to cover the introduction of statistical estimation, then we have to learn the meaning of some terminologies. Remember that I'll be solving a lot of questions in this modules. Some of terminologies in estimation. So I've prepared the 8 terminologies. Doesn't mean that they are 8, but I've prepared 8 terminologies. And the first one, I want to teach you the meaning of this word called the estimation. Say with me, estimation. Again, say it with power, estimation. So estimation, you know, this is one of the components of the chapter, statistical estimation. So you want to understand what the meanings of estimation. So that the primary question, the first question that we have to ask ourselves as engineers, what is the meaning of estimation? What is the meaning? Before we do estimation, it's better for us to understand which estimations are we going to do. Numeric estimation, okay, differential estimations. What is the meaning of of the term estimation, right? Estimation. So I found various definitions, but let me present one, at least two. Two are enough. Okay. Estimation is a process. So will be what are we going to do in statistical estimation? We'll be following different process of providing a numerical value, providing numerical value for a population parameter. For a population parameter on the basis of the information. On the basis of the information. On the basis of information. information collected from the sample. Collected from the sample. So this is the one of the definition. Let me give you a second definition, and then I will explain what does it mean. You may use either of these definitions. You have to understand in your mind, even if that you won't be asked in the exam. But we used to do estimation in different cases. For example, everybody is doing budget estimation at the beginnings of the months, or a yearly estimations, or a daily estimation. Today I'm going to spend maybe 10,000 Tanzania shillings or 10,000 Tanzania shillings. So it's estimation. So estimations is all of the human life. But let us learn these special types of estimation that have been taught as engineers. Okay? Some references define the term estimation like this: is a data analysis is a data analysis framework data analysis framework that uses the combination of effect sizes, confidence intervals, right? Confidence intervals, precision. So you see, presenting the terms that I've already mentioned in the subtopic. Precision planning, okay, precision planning, and meta-analysis. Meta-analysis. To plan experiments. Analyze data. And interpret results. Again, I have a short definition of statistical estimation, the meaning of statistical estimation I want to give you, because we have to understand the big picture of this topic. We are engineers. We have to understand the stuff talking about what we are. Engineering is built. For example, me, teaching is built in me, so I am a teaching. Engineering also is built in me, so I am engineering. Okay? So, or we say that estimation are the formulas. These are the formulas. This is according to the formulas. The definitions of the Doctor of Mathematics at the University of Dar es Salaam are the formulas used to estimate the population parameter. You see? Short but powerful. Population parameters. When you say population parameters, such as mean, proportion, we'll be learning all of this, proportion, variance, and the standard deviation. Standard deviation. This is the chorus of our song. This is the chorus of the song, of our song. Standard deviation. So let me explain in brief the meanings of these words in this definition. The questions on spot is, what is the meaning of the term estimation? So estimation is a process. So it's not just like a shortcut, it's a process of what? Providing numerical value, not politics, providing numerical value for a population parameter. Particular population parameter, example proportions, example mean, example standard deviations. So we have to provide numerical value of mean, of standard deviations, of variance, of proportions, of a particular, whether it is finite populations or infinite population, but in a different ways, not like in the ordinary ways of having or dealing with the all population. Sometimes it is critical, because otherwise the research that involving maybe, for example, the all animals or all the lions in the world could be challenged, because to count them and even to find them in a particular place is expensive. So that's why we need these estimations. Okay, so how? Population parameter on the basis of the information. So we need the information, and this information we collect them from the sample. Wow. So now, rather than spending a lot of money and spending much of their time on dealing with the big population, for example, that the African populations maybe want to maybe, for example, do research on the coronas, let's say, or on the any pandemic disease. How did it affect the economics of African countries, for example? So the African the populations of Africa is huge. You cannot deal with them, so you cannot interview them, you cannot maybe ask them questions or give them the question. It is difficult. So we as engineers, we have to learn in engineering perspective. For example, we want to construct roads, we want to design telecommunication system, we want to design the internet system. You see, so we need to take a sample from the finite or infinite population. Then we provide the numerical values at the meanings of the word estimation. Well, the second definition we say that is a data analysis. So this is the data analysis. So it's not collecting. Remember that in statistical estimation we are not collecting data. That is all about statistical one that you'll be learning in O level and diploma level. And even that, if you forgot that, I have some other 2 channels which are teaching all of the facts concerning about those concepts of statistical one, and also even that statistical probability for the diploma students. Okay, so we say it's a data analysis framework that uses what? Combination. So it's combining what? The effect size means that effect size, we take a sample, we affect the size of the original populations, the confidence intervals. Right? Confidence intervals. It means that is interval estimations, that now there's no need for us to have only a point estimator. We can use the interval estimation. Precision planning. We'll be having plan and meta-analysis to plan experiments as engineers. And also to analyze the data and the interpretate results. That means of what? Estimations. All estimations are the formulas. These are the formulas used to estimate the population parameters. So our interest is population parameters, such as what? Such as mean, such as proportion, such as variance, such as standard deviation. I believe that you've understood. In case you have any questions concerning about estimation, please ask it in the comment section. Again, the second terminology is called estimation theory. So mathematicians who discuss such as Gaussian statistical they developed something we call in mathematics estimation theory. So this is the question we have, which is question 2. Define the term or define estimation theory. What is the meanings of estimation theory? The one that we are learning right now, right? So estimation theory is a branch. This is a branch. Is a branch of what? Is a branch of statistics. So this is the branch of statistics, right? It's a branch of statistics that deals deals with estimating the value, with estimating what? Estimating the values, with estimating the values, okay, estimate the values of parameters, okay, or parameters on measured empirical data, on the measured empirical data that has random experiment, that has a random experiment. So this is the meanings of estimation theory. So it's a branch of statistics. It's not a branch of politics that deal with estimating what? The values of a particular parameter on the measuring empirical data that has a random experiment. It means that when you say random experiments, is that this is dealing with continuous random data. That's how we call it, okay? So what it means of continuous random data is difficult to know the exact value, but the actual value lying between the interval of the two values, minimum value and maximum value. So it is lying between, or it's lying within the two intervals. That means of interval estimation. So that means of estimation theory, because the point estimator is just we just learn it less, but the main focus of these lectures will be in the interval estimator, right? So I think that you enjoyed. Good. That's the second terminology. Let us go to the third terminology. Okay? We say again that we have two types of estimation. Okay? Types of estimation. So the third concept that I have to teach you is types of estimation. So we say that in statistical estimation there are two types of what? Of statistical estimation. Statistical estimation. And these two types, the first one we call it point estimator or point estimation. Point estimation will be having fixed value as the result of estimations. At the end of estimations, we have a fixed value. But the second ones, we call it interval estimation. So let us learn the meanings of point estimation. Let us define before we learn it in detail in the second lecture. Point estimation, because the second lecture we're teaching about the point estimations of the mean, point estimation of variance, point estimations of what? Of standard deviation. So the questions on spot is, this is question 3, define what is, so what is what? What is point estimator? What is point estimator? Or point estimation, sorry. What is the meanings of point estimation? There are various definitions, but I've decided to teach you two. We say that it's a single figure. That's what I said, that is fixed. Single figure, meaning it is fixed. Okay, it is single figure calculated. This is a single figure calculated, okay, calculated for the unknown parameter, for the unknown parameter, such as mean, let's say variance, or and so forth, of 40 of the populations, whether finite or infinite population of the population, or some of the references define point estimator that in this way, especially at the Wikipedia. In statistics, that's why I told you I use also the online references. Point estimation involves the use of sample data okay, this involves the use of sample data use of sample data. So this involved the use of sample data. To calculate. Use of sample data to calculate a single value. And this single value is known as, we call it known as statistical value. Statistic, very important, because we find statistic which is used. So this is very important key word, remember it, which is used to serve as a best guess. Used to serve as a best guess. Okay, not like numerical. A best guess or best estimate of an unknown. A best guess or best estimator of unknown. Okay, of an unknown, of an unknown, right? Fixed or random. Okay, fixed or random. Population parameter. Fixed or unknown population parameter. So we have two definitions of this terminology that called the point estimator. Is a single figure, it means fixed value, calculated for a known parameter, such as what? Proportion, mean, standard deviation, variance. Keep those four parameters of statistics. Or in statistics, point estimations involve the use of sample data, which use the sample from the population, to do what? To calculate a single value, the one that I told you here. Calculate a single value, not the interval value, not two values, not three values. And this in statistics, we call it what is statistic, which is used to serve. So this is used to serve as what? As the best guess, right? Best guess or best estimator of what? Unknown population parameter. So what are the unknown population parameter? Mean, variance, standard deviation, and proportions, which might be the new term or new vocabulary, even for myself when I was in second year studies. Okay, so that is all about point estimator or point estimation. So let me take you to 3.4, whereby before I will define later the interval estimator, but let us define the interval estimator so that you can know we can see the difference. Interval, say with me, interval estimation. This now is the heart of statistical estimation. Interval estimation. Point estimator we'll find mostly in a process as a statistical value. We can find also just in the introduction of this one, but especially in hypothesis hypothesis testing, interval estimation. So the question we have, what is interval estimation? What is interval estimation? And the question we have on the spot. What is interval estimation? What is interval estimation? Ask yourself, what is interval estimation before I define? Say, what is interval estimation? Ask your neighbor, if you are watching this video, 2 of you, or 3 or 4 or 5, ask your neighbor, what is interval estimation? What is interval estimation? Ask your neighbor, please. And then give him or her a promise that if you define, I'll give you a gift even. Yes, you see that even just a biscuit is a good gift for you. Okay. So we have this question 4. This is question 1. This is question 3. This is question 4. Okay. So here we go. Okay. Interval estimator or interval estimations, we can define it in this way. In statistics, because you can find it when there's in different cases. Interval estimation is a use of sample data. To calculate an interval of possible, or in bracket we say that probable values of 40 values of an unknown population parameter. Interesting. Population parameter. So interval estimator or interval estimation, we use interchangeably the word interval estimation and interval estimator. So don't get confused, don't get full on that, okay? You'll enjoy, and even yourself, that you'll never forget this material because they'll be written in your subconscious mind. Okay? So that is my prayer for you. So in the use of what? Is a use of sample data to do what? To calculate an interval of what? Of possible values of an unknown population parameter. So it means that we'll be using sample data, sample from the population, to calculate an interval of an unknown population parameter. What does it mean? For example, I can have a finite population. I want just to explain what does it mean. A finite population of 40, many populations of students, right? Students where at Arusha Technical College is, let's say, 1,000, right? So I want to choose a sample, and hence I want to learn about how do they pass engineering mathematics. So I want to take a sample of, let's say, 200 students, right? And then I want to find the mean, right? So when I find the mean, for example, that means if the actual value, you'll find that the actual value, the mean of the students who are passing engineering mathematics in each semester, possibly the means you can find is 30, for example, right? So then it means that the interval estimator now, we say that we can find that, we can say that this is 28 less than or equal to the mean Okay? And then this is less than or equal to, let's say, 31. So you find that the actual mean of these populations lying between the lower interval and the upper interval. So this is what we call the interval estimator. When you say point estimator, that for example we say that mean, in this way, for example, we say that mean is equal to 20. That's the meanings of interval estimator. Or mean, for example, if that we are doing the same experiments of researching the students and the graduate students at Arusha Technical College, it means that who are passing engineering mathematics in every semester, then we find that you have the point estimator is 30, but the interval estimator is 28 to 31. But the problem, okay, point estimator is good because it's giving us a fixed value, but the challenge is many real life problems in that we want to model by using statistical concepts are not resulting in the fixed value. Most of them are resulting in finite estimator. So that is all. So I mean that if you want, I want to claim this because I want to keep on defining some terminologies. If you want to write what I've written there, please pause the video and then copy. In case that you find I'm going too fast, please pause the video and then repeat the video several times as you can. So again, we have the fifth terminology, which we call the estimator. The one I pre-mentioned in my presentations or in my teaching. That is, give us the question number 5. And the question number 5 asks you that define estimator. What the meanings of the word estimator? Okay? So I found 2 definitions of estimator. Say that is a statistic used to provide okay, is a statistic used to provide an estimate for a parameter. So this is the statistic used to provide an estimate for a parameter. Or some of the references, if I explain the meanings of estimator, define this way that is a statistic. So this is a statistic. Is a statistics whose values depends on the particular sample drawing, the value of estimator is used to predicting the value of population parameter. The value of population parameter. The value of population parameter. So ask your neighbor the meaning of estimator before you try to understand what I've written there. Okay? So we say that estimator is a statistic used to provide an estimate for a parameter. So this is a statistic, or it's a value that used to provide estimate of parameter. We can have interval estimator, you can have point estimator, remember. Or is in statistic, we say that it's a statistic, so most of them are still representing what the word is statistic. I told you that bear this mind because we have statistical mean, we have statistical variance, statistical standard deviation, statistical proportions, pair that, because in previous two topics we used to have it means that yes, we have the normal mean of population, so we have Bidelius' mean and so forth. So O is a statistic whose depends or not on the particular sample drawing. So this depends on the particular sample drawings. The value of this estimator